Alright, hello everyone. Again, I am Wallaber, and this is a continuation of this project we're working on to make a simple chat game that works with Twitch. Um, Quick reminder of the idea for the game is that it's a small little narrow game that can fit as a portion of the streamer's screen, and it's going to be a prediction game where chat is trying to guess where the little ball will end up as it bounces down these little pachinko-like boards. And we've got some progress so far. So if I hit play now, we have boards that can build collisions and stuff. And we have a ball that can bounce around. And we have the little buckets down here at the bottom. And it can detect when the ball goes in there and says bucket 2 is the winner. In fact, it even sends that message to the chat just as a test. So today we need to try and get the basic game loop actually kind of like stubbed together. And so I'm going to start with being able to record what happened, because we're going to need to be able to play it back. And so I have a plan for this. So we're just going to make a simple thing called board recorder. This is going to be our script to handle the idea of recording what's going on. Okay, and so it's basically going to find all the objects in the board that need some kind of recording and handle asking them to remember, to store their state every update, and then they'll be able to restore that state for playback. So we're going to have an interface called board recordable. So this is what, if you're a script on the board and you need to be recorded, you need to implement this interface. And we're going to keep this super simple, I think. So we're going to be like, we expect you to have a thing called void capture state, and it's going to expect you to return an array of objects. Okay, like this. And then we're going to have a void restore state, and you're going to get past an array of objects like that. And let's just and then we're going to have two other things. We're going to have void on recording start, and we're going to have a void on playback start. Something like this. Okay. Then what we'll have is that this board recorder script. Let's go ahead and give it a reference to the. Do we have a thing called board yet? Level board. Okay. So this is the target board. Okay. And then we're going to have the actual data for each object. Let me think about how we're going to do this. Yeah, we're going to remember this per object, I guess. This is going to be very simple. This is not going to be the most efficient way to do this, but I don't mind because I want to make this quickly, and because I know this game is not going to suddenly have hundreds of objects or something that I need to record. So we're going to do the quick, easy to understand, but not necessarily most like scalable or robust solution for this. So we're going to have a thing that's like private class, which is just called a recordable state list. Okay. And in here, we're just going to have a public list of an array of objects, and this is going to be our state list. Okay. We'll see. We might need more things than this, but for now, we're going to have that. And then this class, class is going to have a private dictionary, where the key is an iBoard recordable, and the value is its state list. So this is going to be recordable, recordables, recordable states, state lists. Okay. So then what we can do, and maybe we'll have a thing here that's like, I don't know, public enum recorder state, and it's like none, and it's recording, it's playing, okay? And so then we'll have a private recorder state that is our state, and it's going to start as none. Okay, so we're going to have some kind of game manager class or something that's going to manage this pretty directly. So we're not going to worry too much of, we're not going to make this class do anything automatically. You're going to have to call methods on it to make anything happen. So first we're going to have one called public void prepare recording. What this is going to do, and actually we could just pass it the board right then. Let me think about that. Nah, we'll just do it this way. It's fine. So prepare recording is going to find all of the iBoard recordables in the target board. So target board.get components in children of type iBoard recordable. Okay, and I guess when we do this, we want to clear any existing state. Not underscore state. What is this? Recordable state list dot clear. So forget anything we had before. If we did, I don't think we will in most cases. And we go find all the things that inherit from iBoard recordable, and we're going to loop through them. Right? Recordable in recordables. Okay. And then we just need to set up an entry in our list here. So we're going to say recordable state list. The one for this recordable is going to equal a new recordable state list, which is just going to create this empty array of states. All right, so there we go. We should be all set now. Now we could do something like public void start recording. And this is going to, first of all, it's going to loop through all the board recordables in our recordable state list.keys, so just the keys. And we say recordable dot on recording start, just so they get notified in case these guys need to do anything to prepare for recording. And then we will set our state to recording. And we're probably going to want to be able to get this, so we'll do a public recordable state. I don't know, just call it state, I guess. Why not? And you can get it. That just returns the private member. Okay, now I don't think we're going to do anything else in here. Now we'll do public void capture state. We would call this once every update. So if state does not equal recording, then we could probably be like debug.log warning trying to capture state without starting recording or something like that, and we return. Otherwise, very simple. All we're going to do is we're going to for each. In this case, we want to loop through the key value pairs in our dictionary. So the key to the dictionary is our iBoard recordable. Oops, our iBoard recordable, and the value is the recordable state list. KVP is our little local instance of this key value pair in our recordable state list. So we're going to loop through all these, and we're going to say go to the recordable and say capture state, and that's going to return an array. And so we'll do kvp.value.add. Right, this is a list, right? Yeah. Oh, value.statelist.add the results of that. So we're just going to be creating these array as an array. We also need to know, we want to know how many states we captured. So we're going to have a private int captured state count. Okay, and whenever you prepare the recording, we would reset this. And whenever you start recording, we would reset this, I think. Yeah. That reminds me then, we may need a clear state. Oh, these guys don't need to know that. That's okay. So what we can do is here, we're actually going to just do this. Recordable state, no. Let's not loop through just the keys here. Let's loop through and get both the keys and the values. So we can clear any recording by doing kvp dot value dot state list dot clear, and then kvp dot key dot on start. Okay, and then we'll say, yeah, we definitely have no captured states at this point. Okay, so now when we call capture state, we make sure we're in the right state here. We go through and we tell everyone to capture one, and then of course we increment this variable to keep track of how many states we captured. Okay, then you would stop recording, or you would start playback. Okay, so this will do a lot of things similar to start recording. And we're probably going to want a private int playback, frame. Okay. And so start playback is not going to clear out recordings, but it is going to let these iBoard recordables know that playback has begun. And then we're going to set our state to playing, and we're going to set playback frame to 0. Okay, then you can be like public void next, what should we call this? Step playback. Okay, and this will just be like playback frame equals math.min, so whichever is smaller, playback frame plus 1 or captured state count minus 1. So we don't want to go off the edge of our arrays. Okay, and then we can call update replayables. Okay, and then we're also going to probably have a function that's like public void set playback frame. It just sets it manually. And then also calls update replayables. Okay, and then we're going to need to be able to get at the captured count. So this is going to be public int captured frame count. Suddenly we started calling it frames, so might as well do that for the public of this. Get. We're just going to return this. Okay. And we could probably add one for this too, just in case we need it. Playback frame has a getter. Okay. So then down here we're going to have a private void update replayables, and this is just going to loop across all of our replayables, and we're going to say kvp dot key dot restore state, and we're going to pass them kvp dot value dot state list playback frame. So I'm not going to do any interpolation here or anything. We're just going to capture frames and be able to play back frames. If we wanted slow motion or something, we could later add some kind of interpolation to this idea. But not super important at the moment. Okay. That should be the basics for what we need. We could add in like a stop recording that goes back to the idle state or the none state, but I'm not too worried about that. And I guess these really should have a thing like this, you know, where they're like, hey, trying to play back state without starting playback. Might as well try to enforce that I'm gonna do this in the right order. Okay. All right. And then now what we're gonna do, first of all, see if we have any compiler errors. Doesn't look like it. Okay. So now what we're gonna do is we need a way for now to just record the ball. And I'm actually thinking about having the ball be a child of the board as well. Okay, so the ball just needs to record its position and its rotation. So we're going to make a C# script called board recordable transform. Okay. So what this script is going to do, it's going to be a pretty simple script. It's just going to inherit from iBoard recordable, which means it's going to need these methods. Okay. And that's all it should need. Although we will probably want to do private transform cached transform, just because calling .transform can be a problem. If you do it over and over again, it's a little slower, so it's a good idea to cache it. So we'll do that. Okay. So we need to fill out these methods now. Okay, and we're just going to keep this super simple for right now. We will probably record the local position of the object and the local rotation. So what we will do here, in order to capture our state, first of all, we can say if cached transform equals null. Then let's go find it. Cached transform equals this dot transform. Okay. So now we should be able to be like return a list of objects. First object in the list is cached transform dot local position. And then the second thing is cached transform dot local rotation. Okay. And we're just going to return that. Okay, and then restore state's going to do kind of the opposite. So first of all, we'll check if we have a cached transform. We should by now, because we usually record before we play back, but let's just be safe here. Okay, and then we can just be like cached transform dot local position equals vector3 data entry 0, and then cached transform dot local rotation is quaternion coming from data 1. And we will probably have a thing like this: serialized field, private bool, set rigid body to kinematic during playback, which would be defaulting to true. So then what we can do is on playback start, first of all here we would be like, do we have a rigid body 2D? RB 2D equals get component. Yeah, just I guess we want just regular old get component. Rigid body 2D. Okay, if RB2D is non-null, then RB2D dot is kinematic equals false. I guess we'll actually need 2 of these. Now, if this is true, it's the kind of rigid body that is going to be dynamic during recording and should be kinematic during playback, so we can basically when recording is happening, make sure it's not kinematic, and when playback is happening, turn it to kinematic. Okay. There may be other things we want to do here, like disable colliders, for example. Private bool disable colliders during playback, which we probably would want to do. You know what? I feel like I'm going to duplicate this logic somewhere else, but let's go with this for now. So then we also have a thing where we're like, if disable colliders during playback, then collider cols equals get components in children collider 2D. Sorry, collider 2D. Okay, and then for each collider 2D, call in cols col.enabled equals true, and then we do the opposite down here. Equals, oops, yeah, equals false. So these would be opposites. Okay. Okay. Now, in theory, we should be able to go back to our setup here, go to our ball prefab, and tell it to have a board recordable transform. So we want to record this ball's transform, and then the test board needs a board recorder. And the target board is this board. Okay. Okay. Now we need to test if this works. So we're going to start making the all common game manager, right? Game manager is going to be our main script, and we're going to have high level game state, which is going to be simulating, voting. Let's see. So we simulate, then we reveal. So we're revealing the results slowly. Then we have score recap. And then we have go next board, something like this. Okay, so private game state equals game state dot I guess we're gonna say go next board. Maybe it's like load next board, and then it's show next board, something like that. So we're actually going to start in the state of loading the next board, I think. Okay, and then we're going to need a, we'll just do public for now. So game board, or no, we'll do, yeah, public game board, what is it? Level board? What do I call it? Level board. Current board. Okay. Okay. Now we're not going to do all the logics first, but what we will do. 1 second. Okay, so what we want to do is just try to, let's actually do this. Let's do, let's just have a none here, and we'll start on none. Okay, and then in start, let's just go directly to, we have a function called set state, and we're going to say go directly to game state dot simulating. Okay. So let's go build this function. Private void set state game state new state. Okay, and then so we're just going to set state to the new state, and then do different things based on based on this. So we'll use a switch statement, why not? Okay, none doesn't do anything. Case game state dot simulating, and we can just be like start simulation. Okay, case game state dot revealing. We'll be like go reveal sequence. Okay, case game state dot what else we got up here? Score recap. Go score recap. Case game state dot load next board. Okay, and this for now we're not going to do anything. Just keep the same board, and then we'll do case game state dot show next board break. Okay, and so this needs to be show next board, and this needs to be set state, and there we go. So now we need these methods we invented: private void start simulation, private void go reveal sequence, and private void go score recap. Okay, so what we want to do now is start simulations. We're going to need a few things here in addition to the board, right? We need yeah, and so for now, let's think about this. Let's actually do load next board. Load next board for now is going to just set up some things. So we'll have this function called init board, and because we're going to need a reference to the board recorder. And then trying to remember, bucket trigger has a callback, and it was calling it on level board, right? Yes, it was. Cool. Okay. So we're ultimately going to want Game Manager to know about this. So we'll figure that out. Let's go like this. Private void init board. And for now, all this is going to do is just get us the recorder. So recorder equals current board dot get component of board recorder. And then we're also going to do, let's do this. So can the board, low level board, give us, it knows about its let's see, here is where it actually tells the triggers about this. So what we're going to do is we're going to add some callbacks. So we're going to have a public system.action int, which is on, what is this? On ball entered bucket. Okay, and then this is sort of like a callback to a callback, but when the triggers tell us that the ball entered, we are going to say, okay, well, if we have an on ball entered bucket, then we're going to call that with the ID. Okay, so then what we can do is here, when we init the board, we can say current board dot on ball yeah. Now we don't really want to double subscribe to this. So we'll do this though. We'll say plus equals ball entered bucket. And then what we can do is later we'll unsubscribe for this. So then we will be like private. Okay, so then we say start simulation. Okay, a couple things we need to do. We need to go here and go edit project settings and physics 2D. We do not want to auto simulate. Yeah. Okay. Because, so now if I hit play, oh, well, I have compiler errors. We'll get there in a second. So start simulation is going to say, we're actually going to do this in coroutines. Sim routine. Okay, which is just going to be right here, private enumerator sim routine. Okay, and the first thing this is going to do is going to call recorder.start recording. Okay, and then it's going to be like bool, or no, int bucket ID equals -1, and int frame count equals 0. We can say while bucket ID is less than 0, and this is just a failsafe, frame count is, you know, less than, I don't know, 10,000 or something. We probably need a variable for this somewhere. We are going to do what? So we will do physics 2D dot simulate, and we can just use time dot fixed delta time. Yeah, I guess we'll want to do float elapsed equals time dot delta time. Can we do, hang on, yield return new wait for fixed update? Perfect. Okay, so we're going to do this in fixed update style. So we can do physics 2D dot simulate time dot fixed delta time, and for now that's it. And then what we need to do is that ball entered bucket, which will be right here, int idx. Oh, yeah, okay, so we're gonna need this as a private int bucket ID. Okay. And when we start a simulation right here, we're just gonna make sure we set bucket ID to -1. Oh, and then in here we need to be doing frame count ++. And here we need to be checking if bucket ID is less than 0. Then here we would just say bucket ID equals IDX, and then we'll also do current board dot on ball enter minus equals. We don't want to be told anymore. Okay, so we should, when we get down to here, we should be ready to go, and we're going to go to the reveal state. Okay, and now so we're almost there now. What should happen, right, is on start, we're going to call load next board. Load next board is just going to init the board, get us our reference here, and get the, actually let's get rid of this here. Let's do this in starting simulation. Right here. Or even like here. Maybe some of the static stuff we can take out of the coroutine just so it's sort of like more clear that we're doing setup stuff here. So when we start the simulation, we say, okay, let us know when the ball hits the thing, reset the answer bucket, and start the sim. And then the sim is just going to walk through and simulate this. Now later we're going to want to actually do this faster than real time, like simulate multiple steps per frame. But for now, we're going to actually watch it do the simulation at real-time pace. Then it's going to go to revealing. So go to revealing, which calls this. And this is going to do a few things, right? It's going to call And actually, let's again, all the stuff, one-off stuff, let's put up here. Like that. Okay. So now, for now, we're just going to go into an infinite loop here, where we just say while true. We do some stuff, but before, no, it's going to be in a coroutine, sorry. So we're going to say recorder dot start playback. Anything else we need to reset or change? I don't think so. And then we call start coroutine reveal sequence. Okay, not go reveal sequence, just a new thing called reveal sequence, which is a private IE numerator. Reveal sequence. Okay, and this, well, let's loop a few times, right? So for int I equals 0, I is less than 5, I plus plus, let's say. We're going to loop through and play back this thing. So we do for int frame equals 0, frame is less than recorder dot captured frame count f plus plus, and then we do recorder dot we're going to do this fully manually, so we will say what was it, set playback frame to f, and then yield return new wait for end of frame. Now this is actually, it might play back slower or faster because this was per fixed update. I guess we could do this in fixed update. Wait for fixed update. Okay. So what this should do is we loop through the whole playback 5 times. And then we'll just say set state, game state, what was it, load next board? Which should just repeat the loop now, because when we call load next board, we just refresh this, and then we need to actually start the simulation, right? Yeah, so right now what we're going to do is we're going to call set state to go to simulating. Okay, I think we've got most of the basic junk here. So let's see how much we got right and how much we got wrong. Okay. All right, we're good with compiler errors and junk. So the test board. So now we need to make our game manager, right? Which we're going to put up here at the top, and give it the game manager, and it's going to have a reference to its current board, like this. Okay. Let's see what happens if we hit play. Okay, so we're simulating the ball, and actually let's pause and let's look at our game manager. So yes, we're in the simulating state right now. The bucket ID is -1. As soon as we hit here, ball entered bucket 2 happened, and that was it. Bucket ID stayed at -1. Okay, so what did we not do right here? We called init board, then we called set state simulating, and set state simulating should have called start simulation, which should have set this up. Okay, and we did make it into there. So let's make sure, I mean, we must be getting into here, but are we? Let's go back here to level board, and let's step into this and see if we're not making it into here or what the deal is. And let's just go check this code one more time. So this is setting bucket ID, which should get us out of this while loop. but it didn't, so let's start there. Okay, attach the debugger. All right, go. Okay, so we are simulating ball, or the thing is falling. I'm gonna go over here to the right. Boom, hit the breakpoint. Okay. We do go into this, which is setting bucket IDX to 2. Okay. Here, bucket ID is still -1. Why is that? Interesting. Okay. All right. So we have the declaration here. We set it there. We look at it here. And we set it here. And that's it. So what's going on here? Okay, let's attach again. Okay. So on play, we're starting the simulation. We set it to -1 there. Okay. We see that we got a 2 here. We make it to here with a 2. Bucket ID is -1. After this, bucket ID is 2. Aha! How are we getting back into start simulation? Because when we call, let's go here, sim routine says we're done. Let's go to reveal. Reveal says go reveal. We go into the reveal sequence. And we made it all the way to here somehow. Okay. Oh, right, because I'm not capturing anything. Okay, that makes sense. So, and we're not resetting the ball either, so we'll have to figure that out. But the reason is that here in simulate, we can't just do this. We also need to do recorder dot capture state. Record each frame. Okay. Simple cheat. I just changed my name to Bucket2. Hi there. What's up, Edgy Sprat? Nice. So we're getting somewhere here. We have the ball falling down. In theory right now, this is the first time where it's ever actually recorded everything that just happened there. Yep, and now we made it into playback mode. And in theory, it means we're in this loop right now. Are we? Let's see. Yes, we are. So we're on frame 257. Let's go into that. So we come along here. Oh, trying to playback state. Oh, whoops. This should be looking for playing. And so should this. And okay, I should have been looking at my warnings because in theory, I actually was spitting out a warning there. Yep, okay, cool. All right, let's try it again. So we go here. It's gonna bounce into bucket 2 again. This seems pretty deterministic. Okay. Boom. Okay, so now why aren't we getting playback properly? So let's go look at this again. Set playback frame. We should be hitting this method. We are. Okay, yep. When we go into here, and playback frame is 138. So we go into here. We go here. Ooh. Empty. Okay. Oh, right. Okay, we're missing another step. This is great. Okay. We needed to, in probably here in init board would be the place to do it. We need to recorder.prepare recording, so it can go find all the things it needs to record. Okay, we're getting somewhere. Let's try it again. Okay, so it falls. It's going to land in bucket 2. I should get rid of that debug chat log thing. Now look at this. Right now what we're doing is we're playing back the recording of what happened. And see, we're not kicking off the event there because this is a playback. Well, let's prove it now by trying to do something a little different. Actually, let's go ahead and try and do our plan here. So let's do a couple things. Let's see if we can just speed up the sim. Right? So let's just do something stupid like we'll be like, let's do this header simulation, and we could say serialized field private, you know, int sim speed. Let's do 10x just to be wacky. So then what we'll do here is in simulation, we're actually gonna do for int I equals 0, I is less than sim speed I plus plus, and we're gonna sub-step this like this. So we'll do 10 steps of the physics every frame, or whatever this number is set to. So now we should see it play really fast when it's doing the simulation. And then let's try this. Let's try putting in the first pass at how this reveal sequence is intended to work. So let's make a header here. Okay, reveal. All right, so private int, let's keep this simple for now. So let's say, how many chunks do we want to break this up into? And the last one we know will be the one that truly reveals the answer. But so let's say we're going to break it up into, you know, reveal step count. And there's going to be, let's say, 5 steps. Okay. And then we'll do private int reveal step repeat count equals 3. Okay, so the way this is going to work then is what we should be able to do down here is in reveal, we're going to decide some things. So int frames per section is going to be recorder.captured frame count divided by reveal step count. Right, we want to, yeah, if we wanted 3 sections, and let's say it was 300 frames long, and this would give us an answer of 100, which is what we would want. We would want a chunk of 100 frames, then a chunk of 100 frames, and a chunk of 100 frames. Okay, so that's correct. Yep. And then what we do is we go here and we say we're going to loop through up into reveal step count. Okay, and we'll be like start frame is always 0. End frame is going to be I times frames per section. But we should be careful. We might be able to go 1 off the edge here. So we'll set this to math.min of this and recorder.captured frame count -1. Okay, and then we're going to say, so now what we're doing is we're doing for int j equals 0, j is less than reveal step repeat count j++. Because we're going to show this playback a couple times. And then we say frame equals start frame, and f is less than or equal to, I guess now, because of the way I wrote that above there, end frame. Okay, f++, and then we just set the playback and show it. Okay, so let's see if this works. And really, the last one, let's do this. Int reveal steps equals reveal step count, unless if I equals reveal step count -1. Oh wait, this is on like this. Then we say reveal steps equals 1, because we only want to show the final thing once. And then this isn't reveal step count. This is reveal step repeat count. So how many times do we show the subsection? Normally we show it this many times, but on the last one, when it's actually going to go into the bucket, we're going to, and we should actually let it sim past, but we'll not worry about that right now. Okay. All right. So now in theory, if we run this, we should see the ball fall really fast. And then, here we go. There's the first one. Put in your votes. Okay, here's a little more. Put in your votes. Okay, here's a little more. Or, I mean, this is the same thing. Put in your votes, right? Okay, now here's a little more. Boom, 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 boom. Oh, oh. Are you ready to vote yet? Okay. And then this one should go, we have 5 steps, so this should be the last, or now, this should be the last one. Where we see like, okay, and by there, you know, like, yeah, you've got this, right? And we're showing this one a few times, so you can put in your votes on this one. And then it should show us one last loop where it goes all the way to the end, although something's screwed up there. Oh, that's because it's re-simulating, so that's fine. We didn't see the last one, though, did we? Or did we see it once and then it just... Let's check our math here. So let's set this to 1. Let's set this to like 20. Oh wait, not in play mode. Set this to like 20, set this to 1, and yeah, this is 5. So do we see 5 playbacks here? Let's see. So we see 1, 2, 3, 4, and this 4th one gets us to there. And then, okay, so something's wrong with 5. We never make it to it? We never make it to it. We actually need this to be a less than or equals to, right? And then this would actually be if we're on the last one. Right? Hang on. Now if this is 5, we should get 5 loops of this. Oh. Right. The problem here is that end frame needs to be I plus 1. Yeah, okay. Let's test this. And we'll just, since we keep seeing the same thing over and over again, let's give the ball a slightly different starting position. Okay, so what does it do? There you go. There's that. There's number 3. There's number 4. Goes in the center, doesn't it? And then here's number 5. Cool. All right. Let's get rid of this spam in the chat here. Where was that? That was here. So we're not gonna display this in the chat anymore. It's kind of spoiling the answers. Okay, cool. So obviously we can simulate the ball like super fast, so that's good. And then I like this general reveal. This is pretty cool. Like here, it's like, ooh, I think it's going to go over the edge. Do I put in the vote right now and say center? Would have been smart, right? Because we're going to see here that that was, in fact, the case. Ding! Cool. Now maybe we'll want a little more drama to this and stuff. But that is a really good start. So I'm gonna stop for today. I'm very happy with the progress on this. This is great. So the next thing we're gonna do, now that we have this kind of will the game be displayed graphically as an overlay or be injected in a Twitch chat code? No, it'll be graphically an overlay. The reason I'm making it this kind of tall, narrow thing is the idea is that I would reserve some space on my stream for this game to be constantly running. Kind of like when you see like stream avatars some people have where there's little characters walking along the bottom of the screen. This would be like a tall, narrow chunk of the screen reserved for this game, and it would be constantly going. Something that the chat can just always, you know, partially interact with. The chat is real time. The streaming can be delayed from 5 seconds. Yeah. How do you prevent the winner from being shown in the chat before the recording of the game is shown? Right. Well, it's not gonna that thing. The bucket is the winner thing. That was just a test. The game's not actually gonna announce it like that. All of the communication of the winner will be happening on screen in the game. Now you do bring up a good point about the amount of delay some people have. Like I know when I'm on mobile, right, and someone asks a question, streamer asks a question, I immediately type an answer, and then there's like a multiple second delay before they, you know, see it, and that just sort of reveals just how long the lag is or how much behind you're seeing, quote unquote, real time. So that's part of the reason that we're going to need the ability to decide how like I can essentially tune that a little bit right now. Like if I set this to like 5, let's say, and then let's do one we haven't seen before. I'll move the ball, just kind of change the starting conditions a little bit. So ideally what's happening here is oh great, this is no good. I have to fix this. So we simulate the ball. We won't show that part. And then here's where you would be like, okay, get your votes in now. Right now, it's worth, you know, 200 points or whatever. And I'm showing it how many times right now? 5 each. Now, one thing I'm just realizing is that means you don't get a equal window for each one, right? You actually get less time at the beginning, because it's a shorter recording being shown 5 times, so that's a shorter amount of total time where you get to. So probably what I'll do is I'm going to add a thing here that says like how many seconds do you get to vote? And then we can do some math and say, okay, well, if we've got, you know, let's say we want to give people 25 seconds to vote for a segment here, then we work out how many times we can play back this thing in that time frame. And then we'll probably have like a little meter showing like how much time you have left on this one, and then when it runs out we move on and we start playing the slightly longer one. Repeat. So it might not even need to be a fixed number of times. It might just be we keep playing this until a timer expires, a timer that we show you somewhere. Like, get in your votes right now because it's worth 100 points. Get in your votes right now. And we're just going to try and tune that, I guess, so that a round doesn't take ages to finish, but it's reasonable enough that if you're paying attention and get a chat message in, it's captured, despite there being a delay. Let's see, where does this one go? I think this one goes in the center, but it might rebound to the right because we didn't really get to see the bounce off of this wall here. Let's see. Still didn't get to see it. Maybe this time we'll get to see it. Yeah, so we definitely need some feedback on when it's going to move to the next phase. And possibly, it goes to the right. And then possibly we'll actually be showing a trail. So like it will play the ball once and like leave a trail, and that trail will sit there the whole time, and then it's just playing the ball animation, so you get a sense for like how fast it was moving and stuff, but that trail is constantly visible there for the whole time you're voting for that section. And then it would like reset and show it again, repeat. So next time, I think what we're going to do is probably try to get the voting in. So we'll probably set up a little bit of UI like I just mentioned, maybe change the tuning of it so you can set it as durations instead of number of repetitions. Change that logic, maybe toss in a little UI so we can communicate how long you have until the voting is over and pick some score values, and then actually get it responding to commands and keeping track of everyone's votes. And then maybe we can just get like a crappy screen to pop up in between that temporarily just shows like username and points. If we get that far, then the next step would be we need to at least make a couple boards and get the sequence in of actually loading a new board in, revealing the new board, do things like hiding the simulation. I think the plan is I'm going to load the board off screen, simulate it off screen, and then reveal the board and do the playback. And then when it's time for the next one, we load the next board off screen, do a sim of it, repeat. That'd be the simplest way, rather than adding a bunch of code to like hide and show game objects or something. So that's pretty good. Making good progress. And I like the way this is coming together. I think this is going to be fun. You know, it doesn't need to be super fast-paced because it's intended to be something that sits on a stream, right? So streams are more like long form. So, you know, if it's like a round every minute or two, like that's fine. That might be a good pace to sort of mix in with the content of the stream and also still have something going on where every now and then it gets exciting and everyone looks over, you know, and then kind of goes back to the stream or whatever. It's kind of the feeling I'm imagining. So we'll see if that's how it works. Cool. Yeah, so I think next time we'll try and get rudimentary voting in. And then after that, we will have to make a few boards and get the whole thing going where it's actually the whole flow is in. And after that, it will be just refining each piece to make it a little more exciting. I need to fix the colliders on the walls so that they don't have flat tops, stuff like that. But yeah, pretty good. So I'll be back next time to pick up and try and get chat voting actually working. There may be a stream in between where I'm working on ProGymnast. I'm not sure. We'll see how it goes. Thanks for hanging out, and have a good night, everyone.